So we are directly jumping to the next session, which is presented by Jörg Meiners. Jörg Meiners is Principal Sales Engineer at Denodo Technologies, and he's talking about simplifying analytics with an enterprise data fabric. The stage is yours.
Okay, thanks a lot. So, welcome, ladies and gentlemen. Jörg Meiners is my name from Denodo Technologies. I will share my screen with you. Okay, here we go. So, in the next around about 20 minutes, it will be a pleasure for me to show you, explain you how you can simplify your analytics platform with an enterprise data fabric. So, the story is, of course, about doing analytics, doing advanced analytics. And I'm pretty sure many of you will know better what advanced analytics means. So it's not only looking to the past, but also looking to the future, how to use machine learning, artificial intelligence to do a forecast, what will happen or what will happen and how you can influence it, right? So the interesting part of that Gartner slide is that in these scenarios, the value out of these scenarios might be higher, so more value, but it's also more difficult to implement them. And one part of that difficulty is that you might need more data. If you do a forecast, you need more data, more complex data, and maybe even real-time data, because it does not make sense to do a forecast based on data which is 1 week old or so, right? So having the data in place, having access to the data is one complexity. I'm pretty sure you all will know it if you are doing advanced analytics. So now, why is it complex to get data, to get access to data? So looking to your data environment or to data environments that customers usually or companies usually have in these days, it's not only a data warehouse, right? So looking 20 years ago, it was a well-established approach. It was a standard approach to load everything inside a data warehouse. And from that perspective, your analytical platform was easy, right? The data is in the data warehouse and you do the reporting or the analytics on top of it. But meanwhile, in the last 10, 20 years, basically all companies have started to store data for very, very good reasons also in other data sources. For example, they have started to implement data lakes to hold semi-structured data or IoT data for a very good reason. It's in the data lake, right? Or you have data in the cloud, in Snowflake, Salesforce, other cloud services, right? For very good reasons. You have data in files in NoSQL databases. Many other data sources are possible. And again, for very good reasons from an IT perspective, right? But actually that gives you now some complexity to, let's say, have and get access to data, because data is in different data sources. And that is also reflected by this interesting study or evaluation from IDC, which is not too old. It's basically 2 years old, but has been supported by many customers and many companies. So around about 1,000 companies have been asked, how many data sources do you connect if you build an analytical use case? Right? And the answer was, in average, 6. So 6 different data sources. Might be spreadsheets, might be databases, and so on. Of course, quite often data lakes, NoSQL databases. So that is one interesting aspect, which is just underlining what I said before, different data sources, right? On the other hand, another aspect of this study was also that users intend, of course, to use different tools to work on that use case. So might be BI tools, might be analytical notebooks, might be Python, R, or Scala. So different languages, different tools. And that builds basically the complexity of your environment of your analytical platform, right? Different data sources, different users with different end user tools. And you have a kind of spaghetti architecture in between, because you need to deal with different sites, with different protocols, with different data formats, with different copies, with different authorization methods. So quite complex. And that is actually not what you want to care about. You just want to work with your data. So what is the dilemma to summarize that? On the one hand, business analysts, data scientists want more and more data. They want the data as soon as possible, immediately. On the other hand, your data environment is not even same complex as before. It's even more complex. So two trends that are kind of working against each other, right? So what is or what are the analysts recommending for that to make the life easier here? They are talking about an enterprise data fabric. There are different definitions from Forrester, from Gartner, from IDC, and so on, from TDW, but I'm referring to the Forrester definition here because it's quite easy to understand. An enterprise data fabric is, so to speak, a technology, an IT component, so to speak, that delivers the data out of the IT, out of these different data systems, in a very intelligent, in a secure, in a self-service manner, to the business, to the end users who want to consume the data. However, those enterprise data fabric it is doing, it is these definitions do not talk about do it this way, do it that way. They are just feature based. So in the evaluation of Forrester, for example, you see on the right side that there are different providers for these data fabrics in the leaders segment, such as SAP, Oracle. And as you have heard, I'm from Denodo. We are this red button here. So one of the leading companies who provides data fabrics. So what is special about our data fabric? And I will give you show you our data fabric just as an example. So what is specific to our data fabric? We are basically the one and only company in this leader segment who is providing a virtual enterprise data fabric. Virtual means we are not really copying data. We are not really using ETL or replication methods to build copies. What we do is we provide a virtual access directly to the data. So why are we doing that? Because, well, the idea of virtualization, and it is not really specific to us, but a general idea of virtualization is to provide more agility, right? So think of virtual machines, server virtualization. It's not a requirement anymore to move boxes around, to plug cables and so on. It's just rule-based. You ramp up a new virtual server by software, by a rule, by pressing a button, and the new virtual machine is available. And the same idea is with data virtualization, with a virtual data fabric. So how does it work? In just a few words, we have our Denodo virtual data fabric. Denodo is the Denodo platform in between the data sources on the bottom and the consumers, the end users on the top. What Denodo actually does, it connects to data. We are not copying data. We are not removing data. We are not replicating data. We are just connecting to data in place. Might it be an SAP system? Might it be in Hadoop system, Parquet files, an Impala database, classical databases files? We connect to data more or less out of the box. Once we are connected, we are speaking one language on top of this external data, that is SQL language. So you can imagine of this enterprise data fabric as a database. That is actually what we are, technically wise, that has its data not internally, but holds its data really in its original place in the data sources. So based on that, you can now rule-based combine data, transform data. You can build joins between SAP data coming from an SAP and an Oracle database or an Impala database or SparkQL data sources. We can combine and transform rule-based any kind of data. And in that way, we built a kind of canonical data model that finally the end users can easily connect in Denodo. So they will just work on this provided data model from Denodo just as it would be physical data, right? And of course, and that is the most important thing, Denodo is a query engine. That is, so to speak, our excellence. We are executing the queries on federated, on heterogeneous data. And we do it with good performance. And that is our agenda, to work even on big data landscapes. By the way, we have also a data catalog integrated, central point for doing security, role-based security, column-level security, monitoring, auditing. And by the way, we can also cache data. So this is really data materialization. So we can cache data. And in that case, end users are not really working on the data sources, but on cached data. So let me give you an example how this works. A customer example, this is Prologis. Prologis is one of the leading companies building those large data warehouses, these large warehouses, especially for the logistic industry. They are working globally. And of course, their challenge is always cost. So if they do a project building a new warehouse, they want to do it with an optimized cost. So now they want to do some analytics while building this warehouse, if they are still on track regarding an optimized cost perspective. I mean, costs are derived or are developed or implemented, influenced by many, many, many different aspects. So they want to do a forecast. What will be the final cost and how can we optimize it? How can we influence it? So a typical advanced analytic, a typical forecast use case. So what they actually did is they integrated all the data sources they have into Denodo. As I said before, this goes quite easy. They have transformed and combined this data into a canonical data model or unified data model, or let's call it semantical data model. And finally, they have provided this data model for the usage for the data scientists. They, by the way, use Jupyter Notebook and Python to work now on this data model provided by Denodo. So very easy for them. They do not need to care about the heterogeneous data landscape on the bottom. They have a single point of entry and they can just start to work. So by the way, they have been successfully doing it. They have implemented the procedures and the programs, so to speak, to analyze the data in the way they wanted to do that. But now the next question was, well, I do not only have data scientists, I also have, let's say, casual users, business users, operators, controllers, and so on. So people who do not really like to start and parameterize Python code, right? So what are we doing to give them the same insight? So actually, the technology is, I want to keep it short. They have moved the Python code down to a Lambda platform in AWS. So however that works, it's important to understand now, as you can see, we have new tables, new views here in Denodo. And if you run SQL statements on top of that new views here, like should cost and cost prediction, they actually run in the background the Python code in the same way as before. So what have you reached? What is the benefit of that? Well, everyone can now speak SQL language again. You do not start Python code, right? And that actually means that casual users, BI users, can now use standard tools like Tableau to work on this data model, to get the same insight than other people. And by the way, Prologis also established a dashboard to present, to visualize key features of that data model. Okay. In summary of that is, in those scenarios, quite often, not only the data scientists are the stakeholders, not only they benefit from this unified access, but also casual users, operational users, which have operational queries. So performance is important. As I said before, we are designed to deliver performance in big data environments. You would wonder how we do that, because we are not working on a single data silo. We are working on federated queries. So we provide or execute federated queries on different data sources. And that is, of course, more challenging. But again, that is our excellence. That is why we are in the market. That is what we do. We have a query optimizer, to say it in very short words, a query optimizer which is designed to optimize the access down to the different source systems to optimize performance. Anyway, as always, if you work with very big data, it might well be that you must, so to speak, materialize transformed data, because joining them, aggregating them every time from scratch might be still too slow. And that is why we can also do data caching, or I would prefer the word data materialization. So in this red quarter here, what you can see is a typical data model. So you have some base views, you are joining them, you build unions, joins, and so on. You are joining them again to more operational views. And what we actually can do is we can materialize the data on each level of that data model. So that is one way to materialize data, to cache data. The other is called summaries. I don't want to go into details here. You might know it from other vendors, from few vendors who call it aggregate awareness. So basically, that means you can build any kind of aggregations and store it in any of your databases. And our optimizer is aware of this pre-aggregated data and will use that pre-aggregation instead of doing the aggregation from scratch, if it is performance-wise sensible. Now, let me please quickly finalize the benefits here from three different user perspectives. One user perspective is, of course, the end user. The people who want to work with data, the data scientists, the analysts, the BI users. So what is their, let's say, advantage? What is their benefit? You can simply describe that as a kind of data self-service. That is basically what they experience. They have now a single point of access where they find all their data. It's presented to them in a predefined semantical data model. We provide, alongside with this data model, an integrated data catalog, so end users can find their data, can understand their data, they understand the data lineage and so on. And they can use a tool of their choice to work on that data model. Might it be tools connecting via ODBC, JDBC, using SQL, REST APIs, GraphQL, different protocols, different APIs, tool of the choice. The other advantage is from the perspective of people who take care of data governance. So what they will find is a single point of control where they can apply their governance rules. So combinations of data, transformations of data, security rules, policies, masking, filtering, and so on. And of course, auditing. The last perspective is the perspective of the IT, quite often forgotten. What is the advantage for the IT? Well, they are somehow decoupled from the user access because the users will work on a virtual data model, which is stable. So that actually means that you can, in the base here, provide even better innovations like migrating from, I don't know, Hive to Impala or from on-premise to cloud. So IT gets more freedom, more independency to do that. Okay, that was my quick run through an enterprise data fabric. Any questions?
Thanks a lot, Mr. Meiners. It was a very interesting presentation, and unfortunately, as we run out of time, I would suggest to all the participants who have questions as a follow-up to you to just connect to Mr. Meiners on LinkedIn or social media or directly via our platform during this second day of the Big-Data.AI Summit. Thanks a lot for your presentation.
You're welcome. Bye-bye.
Bye-bye.
And good success.
Thank you.